Today we continue saving cables and money because we are going to save more than $300 by connecting all the data from our NMEA 2000, CTalk NG and SIMnet equipment to our Wi-Fi network. So we will be able to consult them from the tablet, mobile, or really from anywhere. But this does not end here, because we will also see how to unify all our electronics, both modern and old, in an NMEA 2000 network to visualize all the data on any of our devices. And all this will be possible thanks to our beloved and versatile Raspberry Pi. You cannot miss it. Today we will learn a lot and get the most out of all the electronics of our boat.
And all that new stuff the Raspberry Pi is going to have, but will I still be able to play video games?
You can still play video games. Nothing changes in your house. Greetings, sailors, and welcome to a new episode of The Low-Cost Sailor. In today's episode, we are going to learn a lot about the most modern communication protocols for our boats, the NMEA 2000 and its derivatives CTalk NG and SIMnet. We will see how we can connect all these devices together and also integrate them with our Raspberry Pi, which will allow us to do several things. Access all the data through Wi-Fi from our tablet or cell phone using applications such as OpenCPN or Navionics. Interconnect our old electronics with the new, for example, using the data from an old wind equipment with CTalk or NMEA 0183 in a brand new display of last generation of Raymarine, Garmin, or any of the most popular manufacturers. We will do all this with OpenPlotter and our Raspberry Pi. We will review the latest versions of Raspberry Pi, the differences between 4 and 5, which one is more worthwhile, and how to start it up to have in a very simple way, so simple that if it gets complicated, we can give you already all our electronics completely interconnected. Almost 4 years ago, we started talking about Raspberry Pi and OpenPlotter. With it, we discovered endless possibilities. We built a very low-cost plotter. We added an AIS receiver for only $12. We revitalized all our old electronics by connecting devices with NMEA 0183 and CTalk. We incorporate a lot of wireless displays on board using tablets, 60 Eurocar radios, and ruggedized cell phones. We learned how to automate tasks, alarms, acquire new data, and design information screens with Node-RED. And yet, you never stopped asking me if you could do the same with the more modern electronics, with NMEA 2000. And yes, you could. The problem is that I didn't have any NMEA 2000 equipment to show you. My boat is more than 30 years old, and I honestly thought, why am I going to buy new and expensive electronics if I can solve it with my Chinese stuff?
Well, for the followers, man.
For the followers, of course, but that costs money, and this already costs us enough. However, with time, after many efforts, sacrifices, and losing a lot of money making videos, the manufacturers started to give us some equipment, and finally the NMEA 2000 arrived on my boat. It all started with the cheapest wind equipment on the market with NMEA 2000. Then came Orca, the Orca Core, a multi-function equipment that basically does the same thing we achieve with our Raspberry Pi. Although more expensive, that's sure more robust and much better. In addition, lately a display has been added and very soon a new depth sounder. So the NMEA 2000 has come into my life, and today we will understand how it works. NMEA 2000 is the most common communication protocol for recreational boating today. It was developed by the NMEA organization, the National Marine Electronics Association, as the successor to NMEA 0183, improving it significantly in many respects. It was introduced in 2001, a time when at the turn of the century it seemed that everything modern had to have a 2000 in its name. Everything was 2000, 2000, this 2000, that 2000, now everything is 4.0. This is changing. NMEA 2000 stands out for its speed, going from the 4,800 baud rate of NMEA 0183 to 250,000 baud rates. In addition, its architecture is significantly improved. While the NMEA 0183 uses a point-to-point configuration, the NMEA 2000 adopts a bus architecture. The bus architecture is based on a single trunk cable that runs end-to-end through the ship. At each point where a device is connected, specific cables are branched from this backbone to each piece of equipment. This configuration is much more efficient and is in fact electrically identical to the CAN bus architecture, the industry standard widely used in vehicles. This makes it easier to find more economical options for connecting to the network that are not limited to the marine environment. The backbone cable is terminated at both ends with network terminators, which are simply 120 ohm resistors. As for the message format in NMEA 2000, unlike NMEA 0183, whose messages were ASCII messages, NMEA 2000 uses binary messages, which are shorter and more efficient for transmitting the same amount of information. NMEA 2000 cables carry both data and power to the network. They consist of 5 elements: 2 wires for the power supply, 2 wires for the data, the bus itself, and a shield for electrical protection and insulation. There are 2 types of standard connectors: the mini connector used in the backbone of installations for large ships, and the most common micro connector in derivations. And even in recreational boats, the micro is the backbone. In recreational boats with micro connectors, you have everything. When micro connectors are used, the network restrictions are 100 meters for the backbone cable and up to 6 meters for each branch. So here I get just enough, that is 100 meters of boat length.
In the Trastolillo, no.
Not enough. We cannot mount the NMEA 2000 network. Not enough length. Hehe. Although the cables are not cheap, the connectors used are the standard 5-pin M12, which allows you to purchase them easily at a good price and make your own cables, as we will explain later. For the bus branches, there are T connectors that cross the trunk and generate 1 or more branches. These connectors may seem a bit expensive, but in reality there is nothing special about them. They are simply splices from the trunk wires to the taps. If we wanted to be very crude, we could even do it without connectors, using a power strip to splice the same color wires. However, it is better to opt for watertight connectors to ensure a more professional and durable installation. In other words, I have even chosen the connectors instead of the power strip. So come on, it's clear to me. So far it all seems pretty standard and affordable, but our friends at Raymarine, Simrad and other brands decided to complicate it a bit, creating variants like SeaTalk NG or SimNet with proprietary connectors on all their electronics. Despite this, they did not innovate too much and even respected the color coding on the lead wires. So connecting one of their devices to an NMEA 2000 network is as simple as cutting one of their cables and attaching an M12 connector to one end, or splice it with a standard NMEA 2000 cable. Super simple. In the post on our website, you will find all the schematics and pinouts needed to interconnect the different networks. To set up our NMEA 2000 network and get the data from it, we will need several things. If our goal is simply to get the data from an existing network, then just buy a T connector for less than 10 euros, if you don't have a free derivation of course, and a 5-pin male M12 connector, about 3 euros, and you've got it. Well, and a 2-wire cable to connect to the Raspberry. If you don't have a network set up yet, well then things change a bit. You will need cables, T-taps or multiple taps, power cable and a couple of network terminators, at least to set up an NMEA 2000 network. All this fortunately is now so common that you can even buy it at reasonable prices on AliExpress. Well, and of course you will need some electronic device with NMEA 2000. That may not be so cheap anymore. Well, it depends on what you're looking for, because for the test that we're going to do, I'm going to use this wind equipment, this one. For less than 180 euros, it has NMEA 2000 support, and you can even connect directly to it via Wi-Fi, and apart from wind speed and direction, it is also capable of transmitting the ship's heel. If you see that you are interested, let me know and we can include it in the catalog of our online store. And finally, it's time to get all the data to be able to access them from our tablet, mobile or anywhere. And for that, the truth is that for me, the unbeatable option is still the Raspberry Pi. For a long time, it has been part of the electronics of my boat, joining all the equipment I already had with SeaTalk, NMEA 0183, and a lot of sensors that I have been adding to know the heel, temperature, everything. You've seen it in tons of episodes. And also, there's a lot of Raspberry options now, from 3, which is almost gone, to 4, and finally also support for 5 in the open plotter. So if you don't already have a Raspberry Pi, you'll need one. For the price difference, and if the small difference in power consumption is not a problem, today the Raspberry Pi 5 is a good choice. If you're just going to use it as a brain for the boat, then a 2 GB is more than enough. And if you want to use it with a screen, or to be a plotter, or to watch Netflix, or to record cameras as I've seen in other videos, I'd go for the 8 GB version. It's funny that the 4 is worth about 2 euros less than the 5, so additionally we will need a CAN bus interface for the Raspberry. And there are several options, both via USB. I leave links in the description as some specific hats for CAN bus for the Raspberry.
What is a hat?
Hat. Don't speak English?
A hat for the Raspberry? A hat?
A hat, yes. It's like another circuit. You put it on top.
A hat, yes. Well, that's a good name, huh?
HAT. I really liked it, and it will help me to organize a bit the ton of gadgets that I already had connected to my Raspberry, the MacArthur HAT. An add-on for the Raspberry that for about 120 euros will allow you to connect all generations of electronics of your boat and is part of the OpenPlotter project, and you can buy it at the official OpenPlotter store. Otherwise, the other option, if you want to connect it only to NMEA 2000, is the CAN HAT, which for less than 20 euros can do the same service for you. I'm going to choose to use the MacArthur HAT to tidy up everything I already have, but we'll show you all the possible options. Well, and for the MacArthur HAT, a box of course. Concretely, there is no box where to put the MacArthur HAT and the Raspberry at the same time, but I leave you the schematics, the STLs to print one yourself. Or if you don't have a printer, you can order a printed one from our online store. And that's it. It's time to tinker. Setting up an NMEA 2000 network is really simple. The most basic network simply consists of an NMEA 2000 device and a power cable. For example, with this setup, you can start up a wind vane and access its data over Wi-Fi or access its data over Orca core, which you also just have to power. You already have GPS, you have accelerometers, you have a lot of information. However, I wouldn't consider this a network per se. For it to really be called a network, you have to at least connect a couple of things, a couple of devices. So to build our first complete NMEA 2000 complete network, we will need a terminal strip, a pair of network terminators, a power cable, and some tap wires. We will build the power cable ourselves using a 5-pin male M12 connector and a sufficiently thick 2-wire cable. Since an NMEA 2000 network cannot handle more than 3 amps, this type of cable will suffice. We only need to connect the positive to pin 2 and the negative to pin 3. And with this, the power supply of our NMEA network will be ready. Well, and put a fuse if you want. To this network, we will connect a Garmin display, which already includes its own cable, of course, for what it costs, to check that everything works correctly. We will also add our low-cost wind equipment. That is low cost and comes without cable. For this equipment, we will have to make our own cable using a male and a female M12 5-pin connector, along with a UTP cable with insulation shield. This type of cable is ideal for the short distances we handle and is also much more economical than the official cables. We have 4 pairs for the 4 cables and the mesh for the mesh. The connection is very simple, and you can follow the diagram to make sure that everything is correctly installed. As a bonus, we will also connect a commercial alternative to the Raspberry, the Orca Core 2. Once all the devices are connected, we simply add power and we have our first NMEA 2000 network up and running. It wasn't so difficult after all. Connecting the Raspberry Pi to our NMEA 2000 network with a CAN adapter is also very simple. The first thing will be to mount everything together with the Raspberry. If you are using a MacArthur HAT or a CAN bus HAT, you will just need to plug one board on top of the other and power up the Raspberry. The MacArthur HAT includes all the screws needed for mounting. In our case, we installed a heatsink with fan on our Raspberry Pi, which requires using the longer connectors between the boards than originally included. We will also connect a complementary power module that will allow us to power the Raspberry Pi directly with the 12 volts of the battery. This is essential to be able to integrate it correctly in a NMEA 2000 network. All this will be placed inside a protective box for safety. The next step is to install OpenPlotter and configure it. We already explained these steps in our episode 11, which we have updated the post on our website just now. If you prefer a faster option, in our store you can buy a SD card with everything pre-configured, where you will only have to adjust the specific NMEA 2000 configuration that we are going to see now. As for the CAN bus data cables and an NMEA 2000 network, each cable is named with an H or an L, high and low. Our CAN adapter uses the same nomenclature. So we will only need to connect, as shown in the schematic, pins 4 and 5 of the M12 connected to the H and L terminals of the adapter respectively. In addition, we must make sure that the power supply reference is the same for both systems, also connecting the adapter to the power supply of our boat. It is very important that both the Raspberry and the NMEA 2000 network are powered by the same battery. If they are not, the voltage difference could generate unwanted currents in the adapter, which could damage it. Once this is done, all that remains is to extend the NMEA 2000 network by adding a T-connector to create a new shunt. On that tab, we will connect the new M12 connector, which is already linked to the Raspberry, and that's it. The cheaper option using the CAN HAT will be very similar. We just have to plug it into the Raspberry and connect the same wires to L and H. We use the same connector as before. We have left the schematic both here and in the web post so you can easily follow along. With everything connected, we are ready to start receiving data from our NMEA 2000 network. Having our Raspberry already working, the configuration will be very simple. Open OpenPlotter settings with the Raspberry connected to the internet. Click on Get Candidates to refresh the list of available software. When finished, click on Refresh, look for the Canvas option and install it. Once installed, we open the new Canvas application. We go to the MCP251XFD tab and select Add Device. Here we will be asked to fill in some data that for the MacArthur HAT we must configure the following. As interface, SPISO C1. Oscillator, 20 MHz, the GPIO of 25. When we confirm with OK, the system will ask us to restart the Raspberry. Once rebooted, we go back to the same tab, select the newly added device and click Add Connection. This will restart Signal K, which may take a while. Once restarted, we check to see if it is receiving data. In my case, to get it to start working, I had to go to the CAN Interfaces section, change the NMEA source option to CAN Bespoke and reboot. Restart the Signal K and voila, we are already receiving data in our Raspberry. Now we can display the same information as on the Garmin display, such as wind data or other data coming from our NMEA 2000 network. In addition, as we mentioned in other episodes, all this information is available via Wi-Fi for OpenPlotter, Navionics and similar devices. All this thanks to the plugins integrated in Signal K. Well, it's time to test it. It works great. In the data browser, we can view data from our sources, including NMEA 2000 and also thanks to the MacArthur HAT, older CTOC devices and NMEA 0183. Even AIS, Signal K has a number of additional plugins that allow us to transfer data between different connections. This means that we can integrate CTOC and NMEA 0183 data into our NMEA 2000 network, allowing our new equipment to work with these older systems. Remember that this is also true for SIMNet and CTOC, it's just the cable and connector that changes. At the same time, we can convert all the NMEA 0183 data and transmit it over Wi-Fi to make it available on Navionics, on our tablet or in viewing apps like this one from NKE that one of our followers recently discovered for me. Thank you very much, Ricardo. A real marvel. There are cheaper, more expensive, simpler, and more complex alternatives. Quarkalec, for example, makes numerous devices that allow transferring data from NMEA 2000 to Wi-Fi, and even to other protocols at, well, reasonable prices. Orca, on the other hand, offers its Orca Core 2, a device that connects to the NMEA 2000 network, and in addition to providing all NMEA 2000 network data over Wi-Fi, includes additional sensors such as accelerometers, high-precision GPS, and other interesting features. Of course, that already costs more than 500 euros. But Orca's products, what I like the most is the display. It's basically an Android tablet, weatherproof, over 1000 nits brightness, ideal for outdoors, and it comes with a wireless charging base that integrates seamlessly into my boat's logbook. That's how my old chart plotter disappeared thanks to this. Orca's device includes its own browser, which is fine, although unlike what Raymarines do, this one doesn't limit the use of other apps of your choice. It's an Android and it's open. Mind you, it does have one drawback. It doesn't allow you to split the screen to use two apps at once if you are using the Orca app. This you have to correct. Well, and that it costs $1,000 is the biggest drawback, although I tell you that it is very good. I had the same functionalities with my 300 euro Oukitel, but in full sun the Orca wins. And then the base is that the base has enchanted me. That said, my favorite option is still the Raspberry Pi. It is one of the most economical solutions. Open, easily expandable, and with many possibilities. It allows you to interconnect various devices, add additional functionality, as we have been showing in our episodes and many more that we will show in the future. Although it is true that configuring it can be somewhat more complicated, but all that is solved by following the steps in our videos correctly. And for those who prefer to avoid complications, in our online store we offer SD cards with everything pre-configured and even the Raspberry Pi customized and fully configured according to the needs of your boat. This last option is one of the novelties that we have just added to our online store, and this is to say that it sounded like an infomercial.
How cold it is.
Well, you'll have your cold that you don't have the official windstopper from the low-cost sailor. This is a wonder.
Again with the infomercial, hehehe.
It's cold anyway, my ears are getting cold. Let's get down to business. We have modernized, NMEA 2000 finally landed in 2025 on my boat. What are we going to do? Hey, in the end, the most important thing about all this is that with reasonable prices you can find alternatives that no matter how much the manufacturers try to put their barriers, well, we are here to innovate, to make our own cables, to interconnect the networks by assembling our own cables, or above all, what I like most, to unify all the data and not have to renew every time something breaks down, to have to renew the whole generation of all the electronics. The old Seatalk electronics, for example, from Raymarine was fabulous, even better than the current one. Then we can incorporate all that information in one place thanks to the Raspberry Pi or devices like these that we have seen. There are commercial solutions, there are those from Quark LED, there is the Orca core. It's very good, it's nice, you can put it there and it has everything, right? They are ready-made solutions for people who want it a little more chewed, but in terms of flexibility, there is nothing like a Raspberry Pi, how to assemble it yourself and how to start growing your ship from there. 4 years has been on the Raspberry Pi on my boat. Well, it has gone from the 3 that we made the first video, we have gone to the 4 and very soon will be the 5. I was already happy with the 3 and the 4, I was very happy. What happens is that, as you all ask us to make cards for the 5, to try with the 5, I have to update, that is, it goes against my nature, but I have to update. That's how I got to NMEA 2000. What will be next? The NMEA 3000? Thank you very much for your attention, sailors. I hope you liked today's episode. If so, please give us a like. Subscribe to the channel. You have the little bell to receive all notifications. You have all the links to everything we talked about in the video, both in the description of the video and in the post on our website. In which also, as we can't fit everything in the video, we have put additional diagrams, how some of the other things we have talked about are connected, because it doesn't fit. We want to give special thanks, and you will see this video with at least 1 day in advance, to our Patreons for supporting this project, for allowing us to continue investing our time in developing videos. Here on the screen somewhere everyone's names appear. In any case, see you in a couple of weeks in a new episode of The Low Cost Sailor.
And I'm sure it's good for playing the 5, right?
5, sure, more with 2 monitors at the same time, with 2 screens. It's more powerful, it's faster.
Good.
You can play old arcades, but better.